In lecture 3, we just finished about the roles in game design. And by roles, we mean different people who participate in creating the games, whether they are programmers, they are artists, they are designers. And you should know the difference between an artist and a designer. They are different people, remember, okay? And you should know from their description who are artists and who are designers and what are their roles. And even designers, we describe three types of designers: the lead designers, the world builders, and the interface designers. Similarly, there were other people, okay? People like producer and director, okay? And then there were some other people, some may be non-technical, like lawyer, okay, who is not technical, but maybe there for some games. Now, we move on to the next topic, which is about game engine. Before we start the topic, think about the topic for a minute. What is a game engine? Do you know about engine? What is an engine? I think it's called متحرك, right? In Arabic, engine, car engine, متحرك سيارة. So, a game engine, محرك, okay, محرك, not متحرك, okay, it's محرك, okay, good, thank you. So, this محرك, what is that? What is the job of game engine? Sorry, car engine. If car engine is not there, okay, what will happen? If car engine is not there, okay, then what will happen in your opinion? The car will not move. Useless car, exactly. If it has good, windows, good direction, and good gear, and everything is fine, good tires, new tires, everything is new, the color is very good. But even if you disconnect one wire from the engine and the engine cannot start, okay, what will happen? The car becomes useless. So the engine is the most important part of a car. Similarly, for game design, game engine is very important these days. Before, like maybe 20 years ago or before that, there were no game engines. So when you create a game, so all the logic, all the graphics, all the actions, every programming code was for that game only. And if you wanted to change the game, you have to change lots of things. If you want to create a different game on a similar genre, let's say action game, you have to rewrite the code of everything. Now, this is not the case with game engines. When game engines came, actually, you started having some things predefined. And you just need to have your own logic and your own players, your own graphics, etc. But the functionality was there for you. So for example, in Unity 3D, you already have the engine for first-person shooter or for a car racing game. The things are already there. You can just change your own people, you can just change your own cars, you can just change your own characters and scenes and the textures, and it will become a different game. Okay, so we will see those things. We start this lecture by seeing what are the elements of a game, what are the things inside a game. So the game is divided into different elements that will get pieced together, that will be combined in the end. Okay, as we discussed in the last lecture, that different people have different roles. Some are like working on the graphics, some are specialized for input, some are good or some are expert in music and sound, some who has responsibility for game logic and artificial intelligence, physics, networking, database, and data files. Okay, we did not discuss this last time, database and data file. Okay, so these different things are developed by different people at different time, and at the end they are combined together. Each of these elements can be further divided into more specific systems. For example, logic would consist of physics and particle systems, while graphics might have 2D or 3D render. Okay, so logic is the actions in the game, and we can divide that into different parts, and there will be different people responsible for that. Now you can see that the game is a complex thing in general. The relationship between these elements can be shown like this. Okay, so we start with some input. Okay, this is the input to the game. The input goes to the game logic and AI part. Okay, and then there is some output. Output can be sound and music, output can be graphics. Okay, the game logic and AI also contains the networking, which goes to the network, to the other people or to other computers, etc., or the server. The game logic also interacts with the world database. What is world database? In your game, there is world, there are things in the world, okay, different objects. So there is a database which maintains all those things. How many objects should be there? When you destroy something, what should happen to the object? Then there is physics in the game. What is physics? Well, physics is very important. Like, for example, there is, gravity, thickle, okay? And then there is, for example, movement of different objects, different parts of objects. So we will model them using physics, and this is the general term used for that. It is well, it contains the same thing as we study in the physia, but there is more. Okay, don't consider this like physia just. Okay, there are many things. Okay, so the world database is connected to the data files. What are data files? You can have data files of music, you can have sounds, you can have textures, you can have images. Okay, so music and sound. Music is really the music, and sound is like those different types of events, like click something or open something, close something, the sound of car engine, the sound of running, the sound of rain, the sound of clouds, etc. Okay, different sounds, maybe hundreds of sounds in one game, or thousands of files, different types of sound effects, we call it. Okay, so overall there are quite a different things, or quite a number of different things in a game, and the input itself has different things, like input in terms of different keyboard buttons, input in terms of joystick, maybe facial recognition, maybe gesture recognition, okay, using ishara, for example. All those things, they form the different elements of a game. The detail is in this slide, okay, that input is used to get input from the user. It could be by text or by mouse clicks. Even mouse, I didn't mention. Yes, mouse is an important input, okay, or a combination of mouse click and keyboard character presses. So you use mouse and keyboard in many games, okay, at the same time. Output is used to give messages to the user. It could be sound or graphics text or video, or some images, okay, graphics or images, etc. Then network is for playing multiplayer games. Okay, database is a database that stores information about the game and the play. Okay, like your scores, etc. Everything is there in the database, and as I told you last time, that when the game changes, new characters are coming, some are dying, etc. This information is constantly updated in the database, and the game logic, or the programmers, the program reads the data from the game database. And then there are data files. So we will be using data files. Well, database is an advanced concept, which means that is required in games which have so many things. In this course, we are not going to use database or the network. Okay, input, that is the most important thing we are going to use, because of course every game has some input that will be used to move the players, etc., move the objects in the game. Then output is automatically that you design on the screen, that will be the output. So database, networks, they are not used, and the data files, yes, we will be using. For example, in one game we will be using images, in some other games we are going to use some other sources, and what else, audio files, okay, and 3D models. These are different data files. So 3D models, it's not mentioned here, but models are also files, and we are going to use that in the game. So game logic and AI is a program that controls the moving characters. Okay, so we can have the moving characters without AI, okay, but game logic is there. So AI is part of game logic. Game logic is broad term. I have discussed this many times, game logic, but we did not go into the detail. What is game logic? So game logic means how do you control the movement of characters, okay, and objects, other things. When should they be moving? When should they stop? What happens if two or more objects they collide? If there is tasadum between them, what will happen? Okay, which one will be destroyed, or there is no destruction, or are there going to be any points? Okay, if you fire a bullet, itlaq an-nar, what will happen? Okay, if it misses a target, what will happen? What will happen to the bullet? If it touches a target, okay, should we kill the target or not? Sometimes a bullet may kill a person, sometimes the bullet may injure a person, just like jarh, not killing a person. So this is all about game logic. Okay, when should a door be opened, when it should not open, for example? When can you enter a building, when you cannot enter a building? When the enemy is going to have fire on you, when the enemy cannot fire, okay, and so on. So the game logic processes the input from the user or the network. Okay, what does that mean? The input is from the user, of course, that is clear, but what is the input from the network? Well, actually, when you are having multiplayer game, so another player who is on another computer, he is doing some action, and your player will have the effect of the action on that. Okay, for example, he's trying to fire on you. Are your is your player going to be killed by the fire or not? That is the logic, and this logic is taken from the input either through network, as I said, or through user, and it contacts the database to animate the object smoothly on the display. Okay, so the animation, the motion, this is done through the input. I mean, input controls when there should be animation, when there should be no animation, and we will see that. Like when the user presses right key or left key, the character will start animation, it will start movement. And when you do the key up, okay, when you remove the finger from the key, no key is pressed, the character will be stopped and there will be no movement normally. Okay, so that animation, start and stop of animation, we will control that through input. We will do that in the game, that when the animation should be started and when should it stop. Then physics is part of AI. Okay, so we have game logic. Within the game logic, we have AI. It's something like this, that if I draw it here, so overall, you have some game logic. Within the game logic, AI is part of the game logic. And within that, you have physics. Physics is part of AI, or physics is part of game logic. So in physics, we compute the movement of objects or characters such as the speed, distance, collision, etc. That is important. Okay, so speed is one thing. It is going up, going down. It is going to touch another object. This is the collision, etc. This is part of physics and it is part of AI. Okay. Now, this is game engine. Remember, previously I showed you the elements of game in the last diagram. If I go back, okay, these are different elements of general game design. Okay, these are abstract concepts. Okay, but when you implement these elements inside the game, actually part of a game engine, they are broken down into this. So there is something, for example, scene graph, okay, memory management, then there is level editor, and all those things, they come. So there is more detail. The game engine is actually controlling lots of things. So how do we do this? We can see that there are two main parts. One in the game. One is the game engine. The other one is the game editor. Okay, so the game editor is when you edit a game to create a game, and the game editor has a level editor. We discussed that. There are level or stages, okay, or worlds. And there is also character editor. Now they are different. Like character editor is one thing, level editor is another thing. And game editor is, you see something which is even different. Okay, so they are different parts. And then there is game engine. And why is this important? Because everything is from the game engine. If you see here, all those arrows from the game engine. So game engine gives you the ability for animation, okay, through programming. the scene graph, how the scene will look like. Why do we call it a graph? Because in a scene, we will see that there is a tree or a graph, like objects within the objects, and they are contained within a scene, etc. We will see that in the Unity we call it the hierarchy. Okay. Then there is memory management. This is done by game engine. When you create new objects, we will do some memory management. Remember this. We will create objects, we will delete objects. If you don't delete objects, it will increase your memory and your game will crash. So you need to do memory management so that those objects which are not used in the game, you delete them. Okay, so this will give you more memory, RAM. Okay, so you want to do memory management. Now this is very easy in the game. Okay, when you see that something is not in the scene in the game, okay, it is in the memory, you just delete that. And that's very interesting. Just within a few line of code, 2 or 3 line of code, you will just do that in different games. So there is graphics rendering engine. Okay, we have 2D graphics, we have 3D graphics, we have video graphics. Okay, and the rendering simply means how do you display them? How do you display something on the screen using 2D or 3D or video resources? Okay, then there is audio rendering engine, for which we have sound scripting. Okay, sound scripting is the script or the code that you write to generate some sound, and that's also interesting. We are going to see that inshallah. Physics engine, and physics engine, as we discussed in the last slide, it has, for example, movement, it has collision, it has gravity, it has different effects. Okay, next component is artificial intelligence. We said that physics engine is part of the artificial intelligence. Yes, in some sense it is part, but you can have it independently and connect them together. So artificial intelligence has rules, what should be there, and these rules are for different roles. So rules are what? Qawaid. And role, what is a role in general? What is a role in Arabic? You have some role. Okay, wazifa you call it, or whatever. This is role playing is adwar. You have some door. Qanun qawaid is the rule. I'm talking about the role. So rule is the qanun and qawaid. This is this, and then this is the role. Okay, so role is like there is the hero, and then there is the enemy, and then there is one character. These are different, you know. No, roles. Door, you can call it door. Is it door, right? So these are different roles. Okay, so this is part of artificial intelligence. Then there are different acts or different scenes. Within the acts you have goals. For every scene, for every level you have a goal, and then there is planning part. Okay, pathfinding. This is totally artificial intelligence. So if you are going to study artificial intelligence course, maybe this semester or next semester, or maybe someone has studied artificial intelligence in your degree program, so there is planning and pathfinding. So we have different pathfinding algorithms. Okay, there are searching algorithms, so they are part of artificial intelligence and they are used in the game, although in this course we are not using it because we are designing simple games. But if we talk about artificial intelligence in games, then planning, pathfinding, they are important parts. Then there are statistics, ahsayat, about different things. You have scores in the game. Okay, who did good, who did not do better, etc. Okay, other housekeeping things. How do you manage things? Housekeeping means how do you manage different resources in the game. Okay, so different files, different resources, different programs, okay, etc. And messaging is one part which is related to the network. Okay, so there is networking, then there is streaming. How do you stream the games? This is a very popular thing. There are YouTube videos on game streaming. Okay, so you can see that in a game app you have different components, and you know almost all of those components. So we define a game engine as the core software of video games. So we are talking about modern games. As I told you, many years ago, game engines were not there. So you would write a game from zero. But now you have the concept of game engine. So that is the core software of video game. A video game is created on top of some game engine. It was developed in the mid 1990 due to simplification to simplify development process of games. Okay, to simplify the software development process of game development. Okay, it runs on multiple platforms. Any game engine, we are talking about general, so you can have game engines on Windows and Linux and Mac. Game engines, they provide what? Physics rendering, graphics rendering, sorry, physics, sound, animation, artificial intelligence, network, and much more. We have discussed these things, so let's go to the next slide. We say that a game engine is a software designed for the creation and development of video games. Okay, this is particularly for video games. Okay, so with a game engine you cannot develop an internet browser, or you cannot develop something like WhatsApp, or you cannot develop an email client, etc. It's only for game design. Although you can develop some augmented reality software with some game engines, like in Unity you can have augmented reality and some training software, okay, for training and education. It's possible. So the developers use them to create games for personal computers, okay, and mobiles and other devices. And like consoles, what are the consoles? We have already discussed, like Xbox, PlayStation, etc. The core functionality provided by the game engine includes a rendering or drawing engine, okay, for 2D or 3D graphics. That is the core functionality, that you draw some 2D or 3D graphics on the screen. Then there is physical engine or collision detection there, okay, sound engine, animation engine, artificial intelligence, and so on. This is repeating the same thing, okay. So the game engine can be used to create different games. That is the important thing. Different games, what does it mean? Different games like first person shooter, third person shooter, car racing games, sports games, etc. Okay, some games are good for some particular types of games. Okay, now there are some game engines. Unreal 3, for example, you can see that is very popular. Game Byro, then CryEngine, Unity 3D engine, etc. Okay, the list is very long. Okay, and I'm going to share with you some game engines. Just give me a minute. Some resources online. So here we see, let's say if we go to Wikipedia. Okay, wait, I did not share the screen. Yeah, okay, it's here. So here, list of game engines in Wikipedia. You can have others. So game engines are tools available for game designers to code and plan out a video game quickly and easily without building one from the ground up. So you don't start from the scratch. You already have many things. You just use those things to create your own game. Whether they are 2D or 3D based, they offer tools to add in asset creation and placement. Okay, the assets are the things in the game. Okay, we will discuss that, but here is a list. So this is alphabetical list for an engine. This is the programming language of C, C++, okay, and it does not have any scripting language. The other one, it is JavaScript, so it is scripting language, which means that it should be available in the browser, I believe. A-frame, you can see this is the web framework for building virtual reality experiences. That's interesting. Okay, so it is cross-platform. You see many of them, they are cross-platform, which means that you can use in different operating systems, different environments, in Windows, Mac, Linux, etc. Okay, so this is proprietary license, which means that it is not open source, and maybe you need to pay to them. Okay, they have certain conditions. Target platforms, wow, so many platforms, Windows, Mac OS. The reason is that, well, it is 4A engine is although in C++, and C++ has many it can be used in many languages. So notable games: Metro 2033, Last Light, Metro Exodus, they are created in this engine. Okay, then similarly this is MIT license. Then there are artistic license, different types of license. So you can click on it to find, like here it says that this license is a software license used for certain free and open source software packages, most notably the standard implementation of the Perl programming language, etc. Okay, so notes for these games, okay, like the Adventure Game Studio is also in C++. but it is only for Windows and Linux. It is not working for Mac, it is not working for Android, etc. Okay, and here it says that mostly used to develop third person, okay, third person games. So they are special to some kind of games, okay, and this is its own language, AGS script, okay, whatever is that language. Okay, there is no information right now, but it is a scripting language. Now this is 2D, some are 3D, but still this is cross platform, okay. Alamo, similarly we continue, Anura, and you can see this is a huge list, okay. Blender game engine was there, but I believe that they do not do it anymore. So you can write in C, C++ primarily, you can also write in Python. 2D and 3D types of games, both. It is class platform for Windows, Linux, Mac OS, and Solaris. Okay, these are the some of the games, okay. uh, do you so see here if you find any games, like I have used this Duke Nukem 3D, I know this, I have played this game, okay, Duke Nukem 3D, and that was a very early game. I don't know, it in 1993 or 95, somewhere there it was created, okay. So this is also first person shooter 2.5D. This is between 2D and 3D, 2.5D. Not exactly 2D, not exactly 3D, 2.5D. Remember this concept, okay? And you will understand the 2.5D when you play the game, okay? It is between 2D and 3D. So I have played Blood, okay? Yes, this was a 2.5D, then Nukem 3D. So this was a time in 1990s, 1995 onwards, 1998, etc. These games were released. So maybe this engine is no more used because of C language difficulty, okay? Okay, there are some other engines. This one is not cross-platform, only working for Windows, and this is the game Memento Mori, okay, created in this one. Apparently a horror engine, maybe. Chrome engine is, another one. This, you see, the Chrome engine has this game list, okay, and this one C4 engine, okay, but okay, so they have this list game. I don't know about this game, okay. So we come down, then there is Coco's 2D. This is very famous, okay, and it has many things: Coco's 2D, Coco's 2D X, etc. It can be written in Objective-C. Now Objective-C is replaced by Swift language for iOS development. I'm not sure how good is that, but in the beginning, this was quite popular for making most of the games in you know uh, iOS and Android. Kodia, you come down. What else do you have? Cube, okay, okay. Some games. So this one has many games. Okay, the Enforce engine. This is not cross platforms, only for Windows. Okay, so these are some games. Okay, then we have, okay, what is the other popular one? I don't know what does that mean. Okay, okay, there is a list of games then. Okay, G develop. Okay, Godot. Yeah, this is also one. Okay, this is MIT license, which means that it is open source. Okay, it has C sharp scripting, Visual Script, GD native, GD script, etc. So that is Godot is one. This is one of the populars, and why? Because it has 2D, 2.5D, and 3D support. So that's good, and you can see there has been quite number of games in this. Okay, even Nintendo Switch port is there. Okay. Okay, what other you have? Hero Engine, Horde 3D. We come down. So ID Tech has some many types of engine, and it has also many games. And we may discuss this. Okay, I will see this ID Tech engine. You see, ID Tech Zero. It was 2.5 cross-platform, very popular games. Then ID Tech One, Doom, Doom 2, Heretic. They were very popular games, all of them. ID Tech 2, Quack 2. They were very popular games. Quack 3. Okay, Wolfenstein, ID Tech 3.5, so all of them, which means that ID Tech was a very famous engine. And you see the versions are increasing. ID Tech 7, okay, so ID Tech 7, and then yeah, until this. Even I think more games will be there. So primarily they were created in C++. Okay, initially it was C, then they moved it to C++. Okay, I come down. Jade was an engine. Okay, it has some things. Yeah, Jade 2, Java 3D engine. Okay, this was for Java, open source. Okay, very quickly I come down. Love 2D is used by some courses. For example, in Stanford course, it uses this Love 2D because it uses Lua scripts. It can be done in C++ or in a scripting language. And because of its capability to have many platforms and because it has many things already built in there, so it is used in many games. Okay, we continue. And monogame SNA, this is also a good one. Okay, this is by Microsoft. Okay, monogame. We continue other things. So monogame has these, games. Maybe we don't know many of them. Okay, we continue. Ogre is also a popular one. Okay, Panda 3D. There are different things. Fire engine, phaser. Okay, this is JavaScript. I even taught this in internet technology course. Phaser.js. This is a JavaScript 2D cross-platform, and like you can make a game very quickly in this, like Mario type of game, you can create very quickly in Phaser. Okay, this is JavaScript coding. They have all the things available to you. Okay, so in computer graphics, you discussed, we studied Canvas. So Play Canvas is 3D engine. Okay, but this is not about Canvas, although it runs in browser, so it is based on Canvas because it is in HTML5. So you already know about Canvas, so this may be useful for you. And JavaScript, you have used that. Okay, so in Canvas, users can work on game at the same time via online browser and publish to multiple platforms. Okay, it uses WebGL and includes physics. That's interesting. Maybe next time I teach that in computer graphics. Okay, Play Canvas. We come down. Sage, okay, Short 3D, Shiva. Yeah, Shiva is also very popular, and you can see there are different platforms, even Windows Phone, PlayStation, WebGL, and Prince of Persia 2. That was a popular game for mobiles. They created using the Shiva engine. Okay, then you have what else? 3.js is just like phaser.js. Yes, I use that in a course. Torque 3D was very popular. The mobile, Blast Gold, etc., they were created. Okay, and then you have Unity. You see the greatest number of platforms it supports. So many platforms. This is the greatest number of platforms. And the list of Unity games, if we go there, this is the reason we chose Unity in this game. So the latest games, if I come down to 2021, these games have been created in Unity. Okay, so maybe you have played some games, Battle Lords and Cloudpunk and Fall Guys, Desperados 3. Okay, I have played Desperados 1, I think. I didn't know Desperados 3 was there, so that was a strategy game. I had played very long ago. Okay, and then there are many other games. Okay, is there any game that you have played that was created in Unity? So there is Iron Man Virtual Reality. Okay, Mario Kart Tour, yes, you may note this. So these are the games which have been created in Unity. And you can see that Unity has a long list of games. Okay, Among Us, you see, Among Us is created in Unity. Okay, and Aegis Defenders, yes, I saw that somewhere. I have not played these games. Runner 3, okay, and maybe you find some other games in there. Okay, so list of games engines is very big, and you have to choose one engine. We have chosen Unity because of the reason that it supports too many platforms, and there is a list of games, and it supports 2D, 2.5D, 3D, and then you can script in C#. In fact, there are some other languages. I think there is even more. I don't know why. Even JavaScript, etc., Lua, they are there, but it has not been mentioned. Okay, So that is about the list of games. Then there is, for example, one specific engine, like you can find many blogs like that. That is SETA engine. Okay, this was done by some students, I think, beginners. So they created, I'm not sure, in 6 months, this whole game engine. And they have all those things in details. Okay, that what did they do in week 0? They started preparation. Okay, in the preparation, what did they do to start a game engine? Okay, about the project, about the schedule, you can see. And this is like doing a game in some course. Maybe they were doing it in course. Okay, so what was not there in the game, what was to be included in the game. Okay, and they created something out of it. Okay, so they did routing. So that may be good for you to understand how do they do this. So they had to learn C++. Okay, and using some videos, etc. Okay, some blogs they used to create the games, the videos, etc. Okay, so what is there? The engine architecture is there. Okay, uh, we cannot go into detail, but there is all detail what is in the engine. Okay, so the core architecture, which is based on C++, okay, which has these things. Then there are the tools. Okay, then there are offline tools, networking, okay, graphics, input, audio. So every detail about collisions, the graphics details, they are there. The gameplay, okay, the game loop, it is going to be very important for us. The scripting. So this is a good read for anyone who wants to actually understand the engine architecture in general, that how do we do this. Okay, so if I go back, let's say home. Yeah, this is home. Okay, then there are resources for the people. Okay, the development of this ISETA, they read these things and they got it. Okay, so for example, game engine architecture second edition, in chapter 4 they had the 3D math for games. Okay, how do they implement 3D? Okay, modern CMake, etc. All those things they were required. So you can see this is a huge list. It's not easy to develop a game. The team behind this game engine, okay, you can see these are students like you. Okay, when they finished, they broke this their computer on which they created the game. So these are 5 students. Okay, they are graduate students studying at Carnegie Mellon's Entertainment Technology Center, and this was created in 2018. So in 2019 they were expected to graduate in the master's program. Okay, yeah, there are many resources. Of course, you need those resources. Okay, so you can see this person, a student, he is the writer and producer. You see this thing. Okay, then this person programming games, he is a programmer. This person is understanding how they work. Okay, so tool development, so he was tool development in charge. Xiao Zhu, software engineering, and has game AI, so he was good in game AI. This person is gameplay programmer designer who enjoys making. So you can see this is a real world example for you people. Okay, that how do they design a game engine. Okay, you understand this now. Just give me a minute. I will close this one and I will go to the last thing shared with you, which is a book, gameenginebook.com. So this is a book which shows you how to create game engine, and you can see these different graphics, for example. Okay, in this book they teach you how to have these details. Okay, so for example, when he fires on this thing, they create different types of holes. Okay, how do they create different types of holes using artificial intelligence? Okay, the diagrams, etc., the models created, you see same model when you make it laugh or when you make it sad. Okay, this is learning, and this is the ogre programming. I told you the ogre engine. So this is C++. Okay, now, because C++ is difficult thing, that's why we did not choose that. We instead chose Unity, which has the easy C sharp. Okay, so come back to the lecture. We were here, different engines it was there in the list of Wikipedia. Okay. Then some open source. Ogre, I just showed to you the last one in the book. So the book was written using Ogre because it is open source. Then Panda 3D, I told you. I'm not sure if it is Panda 3D or Pandas 3D, but actually it was there. Then Crystal Space Engine, okay, which has real graphics like, and Irrlicht is also, yes, interesting. So these are different game engines. They are open source, and you can actually modify them even for your own purpose. Let's say you don't find something, you can change it. Okay, so why do we use game engines? There are some advantages as compared to not using a game engine. When you use a game engine, it requires less development time. Why? Because things are already there. Basic components are there, and we will see with the Unity how easy it becomes with the game engine. Less testing and debugging is required because the things which are there in the game engine, they are bug free. Okay, so they will work the way they are supposed to work. They have been tested by different people before you, and even other people who have used the same game engine. If there were any bugs, they have reported and the bugs have been removed. Many features are directly available. You don't need to reinvent the wheel. You don't need to create it from scratch, and you better focus on the game design and the logic. You don't focus on the low level details, okay, if there is no game engine. The disadvantage of game engine: no control over the implementation because things are already there for you. Adding features not yet in the game engine might be cumbersome. So if there are some features which are not in the game engine, it may take time to add those features, or maybe you lack the features and you cannot use them in your game. And dependent on other license schemes for release. That's the thing, that it has a licensing scheme and you have to follow the licensing. For example, the licensing requires that basic Unity 3D is free, but if you want to publish it, then you pay them, and that will be like their logo will be removed. Okay, and if you want to add some AI, etc., then you have to pay them for that. So you pay them for different things, but of course it's still better to pay them rather than start developing them from the base. This is the typical architecture or different parts and their interrelation of a game engine. So at the lowest level, we start with the hardware layer. Okay, the hardware, it has sound card, graphics card, okay, physics card, AI card, etc. We call them. Okay, so for example, GPU, CPU, they are all in the hardware layer. On top of hardware layer, we have the hardware abstraction layer like DirectX, OpenGL, Direct3D, etc. Okay, so the game engine uses those layers, and the hardware abstraction layer is used by the various parts of the game engine. The AI engine, the physics engine, sound engine, graphics engine, they use the hardware abstraction layer. Okay, then there is scripting engine also, but the scripting engine is related to the other engines. It has nothing to do with the hardware abstraction layer because it's just controlling the other things using scripting or using the coding programming. On top of it, you have the game engine API. Okay, so in Unity, actually, this is what we are going to do. We will use game engine API, which means that existing functions. What is an API? It will give you a set of functions or classes or objects, and we are going to use them in our game. So this is our game. We will write something here, okay, the code or the interface, whatever, that will be connected to the game engine API, which will use them, and so on. Okay, so that is the abstract overview of the game engine architecture. Then you have graphics engine, which generates 2D or 3D animation graphics. Okay, they are built by DirectX or OpenGL. Okay, now it's quite different now. Okay, OpenGL, particularly if we talk about SDL, the Shader Development Library, that is more popular. So the graphics engine uses that SDL. Okay, but it's not part of this book, this course. They provide access to input devices like keyboard, mouse, and joystick. Okay, so using the input of the graphics engine, it can be written in any programming languages like C++, C, Java, Python, and even scripting languages. Graphics engine provides the the graphics engine cannot be written in scripting languages, but the things in graphic languages can be used using scripting languages. So the graphics engine, usually it is C or C++ because they are fast. Even Java is slow, so very few graphics engine are there. So usually it is C or C++ in which you write the graphics engine because they are very low level languages. Graphics engine provide the programmers with application programming interface, which we saw in the last slide. Okay, so if you want to draw something, okay, on the display, you will use the API. Okay, so any type of lighting, shadowing, and making something bigger or smaller or move, this is done through the API. Okay, and the programmer uses the API to control those things. The audio engine is the component which consists of algorithms related to sound. Okay, sound effects, when you play sound, when you stop sound, when you increase sound, decrease sound, when you mix different sounds, etc. Okay, so it supports loading of sound or music from different formats like MP3, WAV, FLV, MIDI, WMV, MP4 audio, etc. Okay, so they play sound and music, stop playing sound and music, sound effects, audio mix, and increase decrease volume of sounds and music. Okay, there are some examples. Physics engine, okay, it is responsible for emulating laws of physics realistically within the application and laws of physics that are there in the real world. For example, right now in my room there is a fan, Meroha. Okay, this fan is rotating with some speed and it is throwing some air. So when you are going to create a fan in the game, you are not just going to say that it is rotating, but because of that there will be some air. The air is going to be in different directions. So near the fan or down the fan, the air will be high, and I am not under the fan, I'm at a side, so the air is low, but still I can feel the air. So this is all about physics engine. Okay, so fluid dynamics, like water, how do you control the water movement? Soft body dynamics, okay, gravity, friction, when two bodies move, they have a friction force between them. Force calculation, is it more force, less force, how much force is required to throw a body? Waves in the sea, explosions, okay, infijar, object destruction, and rigid body dynamics. They are different things. We are going to do some of it, like object destruction, rigid body, gravity, collision. We are going to use them in this course. So box 2D is one example, okay, which is part of the COCOS 2D I told you before. Then Newton game dynamics, then physics 2D. So they are specific. You can see this is not game engine, this is physics engine because they support something related to physics. So you include those physics engine within your game. Now Unity has its own physics engine, so we will not need that. Okay, it has its own physics engine built in. Okay, the final thing is the artificial intelligence engine. What is artificial intelligence engine? Of course, it is what it provides you the just give me 1 minute. The part of the artificial intelligence. Okay, so let's see if we have any artificial intelligence. I searched in the internet. Okay, and I can give you the list here. Okay, let me copy paste this thing here. Okay, so the artificial intelligence engine is what provides what. If you see it, then actually just give me a minute. Yeah, so the detail is there. Okay, it will help you in speech recognition, for example, planning, learning, problem solving. Okay, and how do app developers they use app engines? So everything is there. You can connect them with things. So top AI engine are the IBM Watson. Okay, then there is TensorFlow, then there is Amazon Lex, etc. So list is there, and they are normal artificial intelligence things, but you can use them in your games. Okay, so all of these, I think, except for the last few ones, they are game engines. Otherwise, game specific artificial intelligence engines. Otherwise, the top 5 6, they are general artificial intelligence engine, not for the games. Okay, So with this, we will stop the lecture. Okay, I will stop the recording.